What is a function? And identifying functions from a table or graph. So let's start with what is a function. A function's a rule. It's a very specific relationship between your independent and your dependent variable. So these are all examples of functions, and what we're going to do in this video is we're going to look at tables and graphs and see if we can determine what the function would be. Now before we proceed, I just want to show you this because sometimes when you're looking at a math textbook or online, instead of writing y, you'll sometimes see the f of x, the function of x, and it's exactly the same thing. In fact, what I've done here is just replaced all the y's from that previous slide with the f of x. It's exactly the same thing. Okay, so how do you find the function or the rule from a table? Well, we're going to start by using my latest invention, my function machine. So what we have up top here, 4 numbers, and these 4 numbers are all going to represent x values. Now remember, your x is your input and your y is your output. So we're going to put these x values in our function machine, and we're going to see if we can guess what the function or the equation would be based on the numbers we're putting in. So let's just start with 2. I'm going to put 2 in, and out comes the number 6. Now right away I see 2 possible equations. So what happened to the x? Well, it increased by 4. So perhaps our equation is x plus 4. But it is also being multiplied by 3. So we could have, the equation could be y equals 3x. Let's put some more numbers in our machine and see what happens. So I'm going to put 7 in, and out comes the number 11. Well, that clears things up a little bit. I know it can't be this one, because 3 times 7 would be 21. So it can't be that equation. It could be x plus 4. And if it is, then 13 should come out 17. Let's see if that happens. So I'll put 13 in, and out comes 17. So it looks like this is going to be our equation, or our function. So I'm going to put 25 in, and this should come out 29. And it does. All right, let's look at another example. So here we have 4 input values, 4 x's. We have 2, 5, 6, and 9. So I'm going to put that in our table, 2, 5, 6, and 9. Let's put 2 in and see what comes out. So if 2 goes in, we have an output of 5. So this could be really easy. Could be y equals, what's happening to the x? Well, it's increasing by 3. So perhaps this is just y equals x plus 3, which means the next number, if I put in 5, 8 should come out. Nope, we get 11. Now this one is a little tricky, so I'm going to put in the other 2 numbers, and let's see what we get out. We put in 6, we get 13. And last but not least, we're going to put in our value x of 9, and out comes 19. Now this is tough. This is actually a tough one. If you look at the relationship between x and y, it might take you a few minutes even to get this one. That's why I love doing these. They're fun. They're like puzzles. The solution to this, I'm just going to give it to you here, is actually what's happening is x is doubling and increasing by 1 every time. That's the special relationship between x and y. Whoops. What was that? Okay, 2, 5. So if you take 2 and you double it, that's 4, plus 1 is 5. If you take 5 and you double it, plus 1, that's 11. If you take 6 and double it and add 1, you get 13. And if you take 9 and double it and add 1, you get 19. So that would be our function or our rule. So let's take a look at some input-output tables and see if we can figure out what the equation or the function would be. Now I'm going to, when I have 2 zeros, I kind of ignore those and I look at the other numbers first. So if we look at 1 and 5, Well, it could be times 5, it could be plus 4. What's happening to the x that it becomes 10? Well, it could be plus 8 or times 5. And the last one, what's happening to 3? Well, it could be times 5 or it could be plus 12. Well, if you notice, what they all share, they all have times 5. So our rule for this one would be y equals 5 times x, 5x. Well, let's see if that worked for 0, because I didn't address that. So it does work, because if x is 0, 5 times 0 is 0. So it works. Now the next one, what happens to 2 that it becomes 0? Well, it might be minus 2. What happens to 3 for it to be 1? Well, that's minus 2. In fact, this one was pretty easy. The rule here would be y equals x minus 2. All right, let's do a couple more. What's happening to the x here? Well, it looks like it's increasing by 4. This is increasing by 4. Oh, this is another easy one. So y would equal x plus 4. That would be our rule, our function. The next one, boy, another easy one. They're all increasing by 6. So our rule would be y equals x plus 6. All right, let's do something a little different. Well, how would you find the rule from a line on a graph? So here we have a line, and we want to know what the function is of that line. Well, the first thing we need to do is find some points and put them in a table. Well, we have one here. That would be 0, 4, 0, 4. I also see another one here. If I run 1, jump 5, 1, 5. And you can grab any 4 points on the line. It looks like 2, 6. So 2, 6. And we have, let's just do 3, 7. So what's happening in this table? What's happening to x? Again, pretty easy. If you look at the difference between these two, they're always increasing by 4. So our equation, or our rule of this line, would be y equals x plus 4. This is a graph of y equals x plus 4. All right, let's do one more example. So here we have a line, and we're going to pull 4 points from it. It looks like it intersects here at 0, 1. 0, 1. And I'm going to pull this point, 2, 3. And I'm going to pull this point, 4, 5. And I'm going to pull one more point, 6, 7. 6 and 7. So, what's happening to the x? How is it changing? Well, it looks like it's increasing by 1 on every single one. And that would be our rule, or our function, y equals x plus 1. Or remember, you could write it like this as well. So that's all there is to it. That's how you determine functions from tables and lines on graphs.